So this is probably one of the most useful things, maybe other than dplyr. You can actually use this in conjunction with dplyr to do a lot of different things. User-defined functions. So we use those pretty regularly. So it basically, when R doesn't have a package or something that you want to do, you would use that user-defined function, and you would make it yourself. So that includes a series of existing functions or indexing or anything. You can put absolutely anything in the middle of it in order to do a certain task that you need to do. We also use this for two other purposes. One is to avoid duplication. So a coworker of mine told us the rule of thumb here. So if you are copying and pasting code more than twice, you should create a function to do whatever you're doing. You do not want to repeat code. So this avoids duplication and copying and pasting, because it's really easy to make errors if you say are running the same code on two variables and you're copying and pasting and changing those variables one by one. It's very, very easy to screw up. So I recommend using user-defined functions as much as possible. So I mentioned this today. This is one of the good big data sets that I knew of. So it is called the Treatment Episode Dataset, or TEDS. I downloaded the 2017 version, but they have really far back. So what it is created by the Substance Abuse and Mental Health Services Administration, so a government agency. They require states to report all publicly funded admissions to substance abuse treatment facilities. So if they're receiving government funding, they have to report those admissions. And it also has a lot of demographic variables and variables about their past substance abuse and past psychological health in them. One thing to keep in mind, this is not a longitudinal data set, so it does not follow the same people over time. So if one person is admitted twice into the same treatment facility in the same state, they will have two different IDs. So the rows are treatment episodes, not people. So that's something to keep in mind, and it's a limitation of this data set. I think they do it for privacy purposes. So this is a really great data set. Like I said, 2017 has 2 million observations alone. So if you wanted to look at substance abuse treatment over time, this would be a really great data set to use. A lot of people don't even know it exists. So it's one of the few individual level data sets that you can use on this subject. So in addition to publicly funded admissions, some states, about half, also report any admissions, whether they use public funds or not, as long as their facility receives federal dollars. So there is a table that you can look at to differentiate which state does which. So that's what we're using today. It's very large. I have a method to my madness. I want to show you how to deal with large data sets, because almost in any data science area or job, you're going to deal with bigger data sets. So that is what we're using today. One thing to keep in mind is that you'll see in my code here, there are several packages that we're using today. Almost all of these, except for maybe dplyr, are used to deal with data. Can you all mute your microphones unless you have a question? I think somebody has theirs on. There's some background. So what we're going to use to read in the data instead of read.csv is data.table. It's a really great package specifically for working with big data sets. You can do all the simple manipulations that you would normally do with a data set, but it works a lot faster. And I'm actually going to get rid of these and clean my environment so you can see exactly how fast they work. So data.table uses a lot of indexing. So if you're familiar with that, you should be able to use it pretty easily. dplyr does work pretty well, but not as well as data table. So keep that in mind. I default to this always when I use large data sets. Somebody mentioned to me when they tried to install the parallel package, this one here, it said something about a 64-bit package. That happened to me as well. So when you install it, just install the package with install.packages that it says you're missing, and it should work just fine after that. So we're also going to go over PER today, which is like a functional programming library, and it can be used with user-defined functions. And we're going to go over parallel with this, which is parallel processing. So I use these pretty regularly with big data sets. So today we're going to work with the TEDS data, as I said. So I'm going to load this. Keep in mind 2 million rows and see how long it takes. It's going through, it tells you, and that's great about it. It tells you how long it has left. It's already 2 million observations already loaded. So if you you used read.csv, I imagine it might take anywhere up to like maybe 3 or 4 minutes if it didn't crash your computer, because that happens a lot with read.csv because it's not memory efficient at all. So do not use read.csv, use fread. So user-defined functions, what are they? I said like you can use a row of functions, or I often perform statistical models with it, and all the steps that need to be done before and after them, so they do not have to be repeated. The last example that I'm going to show actually is this. I apologize if you guys aren't familiar with logistic regression, but I wanted to show a real life example, and I'll explain it in simple terms as much as I can. But the user-defined function structure looks the same every time. So you will assign the function to a certain name. So this function name here is what we're going to call my function that I'm creating here. And it's a very, very simple use case that I'm going to show first. And I'm going to work my way up from something simple that I probably would never use in practice up to something pretty complex that I would use every day. So you always put function and then parentheses after that function. The X and the Y are going to be the inputs that I want to put into my function. So like when you use, say, the sum function, you always have 1 or 2 variables here. So the arguments signify what you will eventually put in. So before this runs, I will show you later, but the sum function here, if we wanted to input a 1 for the X, we would put a 1 in the X position. And you can even put X equals 1 if you want to show simplicity. And then we have a second argument in this case, which is Y. And we're going to put that, if we want to put 2 where the Y is, that's how you would actually run it. You're seeing here, we're using that same name, sum function, and then the 2 arguments are in the middle. Within this user-defined function, we have the sum function, which I'm sure you've seen quite a bit, and then we have X comma Y, which are our arguments that are going to feed from up here down into the actual code. So one thing about functions that I actually did not mention in the PowerPoint, and I probably should have. So you can think of inside a function is its own separate environment. So when you're running something within a function, all the data frames that you have loaded into your R environment before that, they don't carry into the function. You have to put them in as arguments if you want to use them in here. So say I'll go back into the code here. So say you have the TEDS dataset loaded. When you work within that function boundary, TEDS will no longer exist for that function. If we want to include it, we would have to do something like down here. I'm just going to example. So this TEDS.small, we're using dplyr in here. I'm going to show how to use dplyr, which I covered in the last class, and user-defined functions in the same way. So this TEDS data set feeds down in here to that where that dot is. So today is going to be a lot more complicated than anything I've ever covered before, and I'm going to cover it very differently. So I love to hear some feedback, but this is definitely assuming that you have quite a bit of experience with R. So if you're a beginner, this may be a frustrating class for you. So here we are finding that sum.
Kelsey, can I ask you something?
Go ahead.
When you show us the code, can you make the R script window bigger?
Yes, absolutely.
Thank you.
I'll do that right now.
Thank you.
Yeah, so thank you.
Yeah.
Zoom in.
Well, I was talking about
drag
down the console, because I was having a hard time understanding if you were including the TEDs before or after the function.
Well, we're going to go over this code in like line by line. I was just showing a really quick example. We're going to go through this like literally actually line by line, and I'm going to even do some live coding so you can see the process of how you would build it. So I was going down really quickly just for a preview. We're going to go through this in absolute like minute detail, because we're going to go today. When I said that I'm going to do a little differently than before, this is going to be a more of a coding class. You'll see I have a lot less slides than usual, and we're actually going to go through and learn by example in this class. So yeah, we will go through that in minute detail. So once back to this, I appreciate the feedback, by the way, it really helps. So we're going to use that return. So if you want something to dump outside of the function, you'll put that return, and then the result that this is what's going to dump outside of the function or have the function returned. So this result object will be dumped out of the function. So here, sum.function, we're putting in 1 and 2. That is feeding directly into the sum function within here. The 1 will be put here, the 2 will be put here, and your result will return 3. So that is a really, really basic example. We would probably never use this in practice. We're going to work our way up to more complex things that we would actually use. So the first one that I'm going to show in the code in just a second, after I show you the different components of it here. So I actually was looking for an example of something that didn't exist in base R that you think maybe should or would, that does not exist. So a lot of you will probably have heard of the mean, median, and mode. So mean and median are definitely base R packages, but there is nothing specifically to calculate the mode within base R itself. You would have to download a package, and I actually did that, and they didn't work very well and give the result that you would expect. So say you ran into that and something just didn't exist. So that would be a good use case for this. So we're going to create the mode.function. You can call it anything that you want. It doesn't matter. It can be mode_function, mode. It can be anything whatsoever. So then we're going to go in, as I showed before, the function of x. So this is our argument. Notice that there are always parentheses around the arguments, and the entire body of the function, which we're showing here, you will have, I'm not even sure what these are called, but you'll see these symbols, 1, and then it opens up to the inside, and 1 down here. So in this case, I'm just doing a really simple manipulation to basically dump out the most common observation, or the one that has the highest frequency, in our data set. So this will work for any variable. If you just put a vector in here, it will return the most common functions. And you guys all of these are really simple functions that you guys have probably seen a lot. That frequency.table, we're doing a frequency table, changing it to a data frame, like you've probably seen before. And then we're creating mode value. So we're using simple indexing to take the row, to pull out the row where the frequency equals the max value within that vector. And so, as you know, this will pull rows and then this blank would represent columns, since we want all the columns. And actually, it probably would have been more efficient to put this 1 in here. So that was a mistake on my part. So you would actually put 1 in here if you wanted to do it efficiently. This will work just fine. And then it prints something with names, like similar to variable names, but just for the vector form of that. And I didn't really want that. So that's all this is taking the names and getting rid of them. And then it's returning that mode.val, which we have created here. And so this is the body of the function, and it's going to evaluate each of these step by step using what you put in this set that X value as. So I'm going to go into the code and kind of show you how this works. So you'll see this monster dplyr here. I usually do the data cleaning after the creation of the data set, and I don't usually show it to you. There is a pretty large code book for this TEDS data set, because when you upload it, and show here, you'll see everything's in the form of numbers. So those numbers actually represent character values. So, excuse me. All that I'm doing down here, I'm going to load this in. You can use read.csv for this because it's tiny. So we loaded this illicit drug data set, and we have our TEDS data set already loaded. So all of this is a recoding. So marital status equals 1 is never married. Marital status equals 2 is now married. The reason I actually included this in here is so you wouldn't have to use the code book very much. So you would know exactly what things originally were and what they have been changed to. So this is dplyr code. Again, we have 2 million rows, so you'll see how fast this works. So it's running right now, and I can go into this. So if you scroll down, once this is complete, it will have all of our new functions in here. So, and it looks like, yeah, so I do not recommend, usually you open, I would show you and open the actual data set, and so it would come up here. Don't do that here because it might crash your computer. It takes a lot of memory to do that. So this is what I created here. It's just simple. The education I changed from numbers into actual character values here. So that's all that is here. So this is what I just showed, the mode function that we just created. So I'm just gonna, when you run a function, either highlight the entire thing like that and click run, or use Control Enter, or put your cursor up here where the function starts, and then you can press Control or Command Enter, and it will run just the same. So you have to run the entire thing at once because it won't understand what's going on here if you don't run the whole thing. So make sure that you are doing that. In my statistics class, when I went over the different functions, user-defined functions, a lot of people weren't running that at once. So just make sure that you do that. So we have that TEDS recode. That's what this data set is here. You'll see TEDS recode. So all this is doing, so this sub 1, if you would look into the code book, it's substance that people admitted to the treatment center have. It's their primary substance, so the one that they have an addiction with. This one down here is a secondary substance. So if they had a second substance in their system, but this was the primary one that they struggled with, that would be put as substance 1. So I'm going to run this. So when I did this, this is our mode dot function, is the function we just created, and I am dumping TEDS.recode and then the sub 1 variable into this function up here. So this sub 1 is going in place of X. You'll know that by the placement. You could also do X equals, and it will work just fine. So when we did that, let's put it as it would very much make sense. Alcohol is the number 1 substance that is in people's system when they are admitted. I'm going to run the next one. So the secondary substance that is most often is actually none. So most people only have one substance in their system when they are admitted. Just for just interest. So this is finding the most common marital status, and the most common is never married. Just as a small, just looking into it. Later, we're going to look at what the maximum number of substances would be, and some other interesting things about it. So I'm going to stop. Are there any questions about that part before I move on? I'm about to move and show you how to actually code it step by step, so that it might make more. If you want to know about the process of how you would do this, that's coming next.